So after having talked about the triangle sum theorem and the importance of that theorem, you would recall that we used a simulation to demonstrate the results of that theorem. And when we drew the triangle, there wasn't a triangle option, there was a polygon option. And so we're here to tell you that by definition, a triangle is a very specific polygon. It happens to be a polygon with exactly 3 sides, and those 3 sides meet at 3 vertices, which you may call angles. And so we're going to go ahead and talk about classifying triangles by their sides and by their angles. So let's begin with scaling. Scaling means that none of the sides are congruent. None of them are equal. So they could be different numbers. For example, this could be 3, this could be 4, this could be 5. And therefore, none of them are congruent to each other. This is in contrast to isosceles, for example, where isosceles, 2 sides are congruent. And so we put these little dashes to demonstrate that they're congruent sides to each other. Notice that the base side doesn't have that little dash because it's not congruent to those 2 sides. We can see that these 2 sides are congruent to each other as well. Remember, congruent means same shape, same size, same length. So for example, if I know that this is x and this is 3, well, because this is isosceles, that means this is also 3 as well, because they're congruent. We can't form any conclusion about the base angle, the base side, but if they're isosceles, the 2 sides that are congruent are equal to each other. Now, equilateral is a very different story. Equilateral means all of the sides are equal to each other. So we will generally identify equilateral triangles with 3 dashes, showing that all 3 of these are congruent to each other. So let's do some algebra. We have triangle DEF, and it happens to be equilateral. If it's equilateral, that means all the sides are equal to each other. So for example, let's take this side and this side. And because they're equal to each other, we can say that this equation is true. Let's get our x's to one side. And then we'll go ahead and move this 7 to the other side. And we found the value for x. Now, that is nice, but we need to find the lengths of these sides as well. So how do we do that? Well, these are the 3 sides for this triangle. We know what x is. We substitute that value in for x, and we follow order of operations. And then we simplify. Well, snap diggity, would you look at that? All 3 sides are equal to each other. Oh, that's because it's equilateral. Oh my goodness, all the sides are equal. Wow. 2 things. First, we got away with that because we know this is equilateral. 2, you could have picked any 2 sides to begin with. You could have picked this and this, set them equal to each other, find the value of x, and then plug them in and gotten the same result. I just didn't want to pick this one because it had a 13 and I got scared of it. But you could pick any 2 sides you want as long as it's equilateral. And that's because these 3 sides are congruent to each other. So we found x and we found the 3 sides length of that triangle. Great. Now we have isosceles triangle. That means that these 2 are congruent to each other. So I'm not going to be using this 2 at all. This is just garbage as far as we're concerned. So we're going to set up what we do know with those 2 congruent sides. We're going to set them equal to each other. Move that 3 to both sides. Divide by 2, and we get an x value of 10. Now, we already know the value of this side. It was 2. We know the value of this side is 17. You could plug this 10 in and simplify following order of operations, and we get 17. But silly folks, we knew this was 17 already because this is 17. It's an isosceles triangle. These 2 sides are congruent to each other. Why do we do all this math? Well, because they wanted us to find the value of x. So we found the value of x. But if they wanted to know how long AB is, and we know that it's isosceles and that AC is 17, we can simply get away with the fact that they're both 17. For your summary, and of course the front side of the notes focuses on sides. How does knowing if a triangle is isosceles or equilateral help in being able to find the lengths of the sides?